Welcome to David Alexander Maths Tuition. This is Chapter 2C on completing the square. Okay, so write x squared plus 4x takes 7 in the form x plus a squared plus b, where a and b are constants to be determined. So we need to recognise that when we see x plus a squared plus b, that means complete the square. Sometimes they disguise it and they might say b plus x plus a squared, so they'll put the b at the front. So again, both of these things mean you need to complete the square. So how do you complete the square on x squared plus 4x minus 7? Well, hopefully you did this at GCSE, but as a refresher, x squared becomes the x. We're going to half 4, so it's plus 2. Now this bracket gets squared. So far, relatively easy. X squared plus 4x becomes x plus 2 all squared. Now the next bit is the bit that people might struggle. Well, it's not difficult, we just need to remember the next sign is always minus. We are subtracting the square of this number, so that's going to be minus 4 and then put the minus 7 back. So we can now clean it up. That's going to be x plus 2 all squared. Minus 4 minus 7 is minus 11. Let's have a look at the next one. X squared takes 6x take 2, so in brackets that's going to be x minus half of 6, which is 3. If this is plus, that is plus. If this is minus, this is minus. Don't overthink it. We're going to square that bracket and we're going to subtract the square of 3, well, or the square of minus 3. It doesn't matter because the square of minus 3 is the same as the square of 3, so don't stress about the sign. So minus 9 minus 2, so that becomes x minus 3 all squared minus 11. There we go. And if you want to just check this out, what is x minus 3 squared? X minus 3, that is x squared, minus 3x minus 3x minus 6x, plus 9, and if I take off 11, 9 take away 11 is negative 2, so you can see it is exactly the same thing. Okay, so it's a little bit harder when we've got an odd number. So x squared plus 3x takes 7, in brackets x plus, now most people would write 1.5, but it's a lot easier to write 3 over 2. So x plus 3 over 2 squared minus, and the reason why it's easier as a fraction is because it's so much easier to square a fraction than it would be to square 1.5. Do you know off the top of your head what 1.5 squared is? Probably not. But 3 over 2 squared, well, that is 3 times 3, which is 9, over 2 times 2, which is 4. Take away 7. Okay, so just tidying it up, x plus 3 over 2 squared. Now 7 is 7 over 1, which is what over 4, so that's 28 over 4. So minus 9 minus 28 is minus 37 over 4. Okay, so this one is a little bit different because we've got the a lots of x plus b squared plus c, so we still need to, it's still telling us to complete the square. So as everything is divisible by 3, I'm going to turn that into 3 lots of x squared plus 3x take away 2. Okay, so now I'm going to complete the square on x squared plus 3x. So now when I complete the square, I create some brackets, but I've already got one set of brackets. So I'll do two different types of brackets. These big brackets are the brackets that I've already drawn, and these smaller brackets, this is for completing the square on the x squared plus 3x. So that's going to be x plus 3 over 2 squared minus 9 over 4 minus 2, big brackets. Okay, so I may as well just tidy up that bit there. So 2 is how many quarters? Well, that's 2 over 1, so that's 8 quarters. Minus 9 quarters minus 8 quarters is minus 17 over 4. And now what I'm going to do is, because it doesn't quite look like we've only got one set of brackets here, I'm going to expand these big brackets. So that's going to be 3 lots of 3x plus 3 over 2 squared minus 3 lots of 17 over 4, which is triple 17 on a dartboard, I seem to remember, is 51, so that's minus 51 over 4. And now a is 3, b is 3 over 2, and c is negative 51 over 4. Okay, this example is slightly different to the previous one, not much different though. So I can't divide all of it by 6, but I can divide the first 2 bits by 6. That's going to be 6x squared plus 3x But the minus 7, I could write minus 7 over 6, or I could just leave it on the outside. So now I'm completing the square on the x squared plus 3x, which is already in brackets, so I'll do two sets of brackets. So that's going to be x plus 3 over 2 all squared minus 9 over 4, close brackets, minus 7. So the minus 7 stays on the outside. Okay, so I'm now going to, sorry, I've got my brackets a bit confused here. This should have been a square bracket, not a curly bracket. Okay, now I'm going to get rid of the square brackets by multiplying out by 6. That's going to be 6 lots of x plus 3 over 2 all squared minus 54 over 4 minus 7. Now minus 54 over 4, let's just write this slightly simplified. That is negative dividing through by 2. Half of 54 is 27. 27 over 2, take away 7, which is 7 over 1. 7 over 1, that is the same as 14 over 2. So that is going to be 6 lots of x plus 3 over 2 all squared. Minus 27 minus 14 is minus 31 minus 41 over 2. So A is 6, B is plus 3 over 2, and C is minus 41 over 2. Okay, so here we're moving on to solving by completing the square. So first of all, let's complete the square. So that's going to be x, take away half of 12, which is 6, all squared, minus 36 plus 4 equals 0. So that will be x take 6 all squared minus 32 equals 0. So we know that when whatever x is, if we take away 6, then square it, then take away 32, we get 0. So let's reverse these steps. So x take 3 all squared is 32. Therefore x, we don't need the brackets anymore, x take away 6 is the square root of 32. And remember, the square root of 32 has both a positive and a negative solution. So therefore x is 6 plus or minus the square root of 32. Of course, root 32, that can be simplified. That is root 16 root 2, so that is 4 root 2. So another way of writing it would be 6 plus or minus 4 root 2. So one solution is 6 plus 4 root 2, and the other solution is 6 take away 4 root 2. And if you're using your quadratic formula to solve it, these are the solutions your calculator would give you. One each depending on whether you're typing in plus the square root of the stuff, and a different one when you change that plus to a minus. This next example, first of all, I need to make it equal 0, so x squared plus 3x minus 2 equals 0. So complete the square, that's going to be x plus 3 over 2 all squared minus 9 over 4 minus 2 equals 0. So that's x plus 3 over 2 all squared. 2 is 8 quarters, so that's minus 17 over 4 equals 0. So therefore x plus 3 over 2 squared equals positive 17 over 4. So I'm kind of running out of space, let's just box this off. So therefore x plus 3 over 2 is the square root of 17 over 4, so plus or minus. Now root 17 over, the square root of 17 over 4, that's the same as root 17 over root 4, which is root 17 over 2. So I can write that as plus or minus the square root of 17 over 2. And now I'm subtracting 3 over 2 from both sides. There we go, sorry, this is awful use of space. So another way of simplifying this, or just cleaning it up, and this is what you'd get on your calculator, that x equals plus or minus the square root of 17 minus 3 all over 2. In fact, your calculator would say root 17 minus 3 over 2 if you're using the quadratic formula, and when you change the plus to a minus, it would say minus root 17 minus 3 over 2. So hopefully that made sense. Apologies that it was all a bit squashed in there. Okay, so by completing the square, solve 2x squared minus 12x plus 4 equals 0. So it's all divisible by 2, so let's divide through by 2. Okay, let's complete the square, so big brackets, x minus 3 all squared minus 9 plus 2. So that's 2 lots of x minus 3 squared minus 11. Okay, let's multiply out by 2, so 2x minus 3 squared minus 22 equals 0. So let's do 2 lots of x minus 3 squared equals positive 22. So therefore 1 lot of x minus 3 squared is 11. So x minus 3 is the plus or minus the square root of 11. So x is positive 3 plus or minus the square root of 11. At this stage here, by the way, there's probably an easier, if 2 lots of all this stuff equals 0, then we could simply have said that 1 lot of all this stuff equals 0. It doesn't really matter. Let me show you what I mean. If 2 lots of all this equals 0, then divide through by 2, then we're getting x minus 3 squared minus 11 equals 0. And at this stage, when I add 11 to both sides, I'm back at this stage here again. Anyway, the key thing is getting the 2 solutions. One is 3 plus root 11, and the other one is 3 take away root 11. By completing the square, solve 3x squared equals minus 9x plus 2, so we need to make it equal 0. So 3x squared plus 9x take away 2 equals 0. I can only complete the square on an x squared, so I need to divide through by 3. And since 2 is not divisible by 3, I'll leave that outside the brackets. So now I'm going to complete the square on x squared plus 3x. I seem to have completed the square a lot on a 3x today. So that's x plus 3 over 2 all squared minus 9 over 4 minus 2. So that is 3 lots of x plus 3 over 2 squared, and 2 is 8 quarters, so that is minus 17 over 4 equals 0. Okay, so if 3 lots of all this stuff equals 0, then I'll do it a slightly different way this time. Then x plus 3 over 2 squared minus 17 over 4 equals 0. I'll just take my workings over to the left-hand side here. So therefore x plus 3 over 2 all squared equals positive 17 over 4. Square root both sides. So that is the square root of 17 over 4. So x plus 3 over 2 is the square root of 17 all over 2. And therefore x is the square root of 17 over, should be a 17 over 2, take away 3 over 2. In other words, x is, again, I've been a bit sloppy, I should have written the plus minus here, plus minus, plus minus. X is plus or minus the square root of 17 minus 3 all over 2. So this final step, which may not have been that clear in my previous example, is just combine, since these are both over 2, just combining them into a single fraction.